Okay. Hello, everyone. My name is Lokesh Kumar Lal. So today I'll be walking you through my project on predicting the electrical energy output of a combined cycle power plant. So this is a regression task, as you see, because our target is a continuous numerical value, and we use sensor data for temperature, vacuum, pressure, and so forth to predict the net hourly electrical energy output. So in terms of the modeling, I selected four primary features for this. As you can see, you have the AT, you have which is the ambient temperature, you have the exhaust vacuum, the ambient pressure, and relative humidity. And based on the algorithms, so I decided to compare two algorithms here. The baseline is the multiple linear regression and a more robust random forest regressor. So essentially, the goal was to see if a complex model could, better capture the nonlinear interactions as well between the weather variables as we described. So if you look at the model building and comparisons, I've split the data into 80% training and 20% testing, and we used five-fold cross-validation. So I found that the random forest outperformed the linear regression significantly, reducing the root mean square error from 4.57 megawatt to 3.47 megawatt. Therefore, I choose the random forest as my final model on the basis of all the analysis. And if we look at the final evaluation, we see that the results are very strong. Our root mean square error is around 3.25 megawatt, but that is, roughly around 1%, and our R square value is 0.9637. So if you even look at the graph on the right hand side, the x-axis represents the actual energy output, and the y-axis shows what the model predicted, and the red dashed line that kind of represents a perfect prediction. So if you notice how the blue dots, spread our model's prediction, the cluster is very tightly, tied along the diagonal line. So this is a visual proof that demonstrate that the model isn't just, guessing. It isn't just random. It has learned the underlying patterns of the power plant's operation with a very high precision. And in conclusion, I mean, this project demonstrates that the environmental variables are powerful predictors of power output. And by choosing a random forest algorithm, we were able to account for complex nonlinear interactions. That is a simple linear, I mean, that a simple linear model might miss. And with an error margin of 3.25 megawatt, which I said is, just like 1% of the average output, this model essentially provides a practical and a reliable way for the plant to operate to, forecast energy predictions. And this could lead to better, grid management and improved operational efficiency and whatnot. So there was my time. Thank you. Thank you, everyone.